if I'm back. Yeah. We're back. Fantastic. Yeah, I had a power outage. That's always fun. But in theory, I'm back now. Okay, at least Twitch can see me. I'm guessing YouTube will see me soon as well. Also, was I wearing the headphones earlier? I have no idea why I was wearing headphones. That's a smart trick for dark mode. Sure, let's do that. Yeah, I have no idea why I wore my headphones. Usually I wear those after I do a stream because, after doing a stream, I have to like listen back to the recording and everything to see that the audio is fine. Let's do this. Oh yeah, how about that? Nice trick. Okay, I'm back. I had a power outage, so that's always fun. But luckily, we're back now. Got it fixed. Okay, so where were we? We're here. Let's try git push again. Let's see what it does. It's running a bunch of tests. All tests ran successfully. Congrats. Okay, so we successfully computed the info hash. Let's see if this is gonna be happy. It's listening for a git push. Oh, I might have to refresh this too because of the outage, which means I need to apply my little trick again. Where's HTML tag, element, this. Thank you very much. Completed. Amazing. Next day. Wow, these smileys look pretty terrifying in inverted colors. Okay. Piece hashes. In a torrent, a file is split into equally sized parts called pieces. A piece is usually 256 kilobytes or 1 megabyte in size. Each piece is assigned a SHA-1 hash value. On public networks, there may be malicious peers to send fake data. These hash values allow us to verify the integrity of each piece that we'll download. Piece length and piece hashes are specified in the info dictionary of the torrent file under the following keys: piece length and pieces. Yes, we already parsed these. The BitTorrent protocol specification has more information about these keys. In this stage, the tester will expect your program to print piece length and a list of piece hashes in hexadecimal format. Oh, I mean, this is going to be easy, right? Because we already have all this stuff parsed. So we should be able to now just do... I guess Yeah, this should just be print line piece length is going to be t.info p length, and then for hash in t.info pieces, I guess .0. We could implement some convenience functions for hashes here, but .0 is fine. Print line. Oh, I see. It wants us to print line piece hashes. And then it wants us to just print the hash. Hex encoded. Okay, so hex encode hash. Easy. Easy. Print piece hashes. Good push. I guess we should get rid of some of these warnings, how they're getting annoying. We don't need serialized map. We don't need serialized sec. What else is it complaining about? That's just output stuff. And then it's also the debug print of the torrent, which we don't really need in here, just to make the output a little less ridiculous. It come in less noise. Okay. So this one's happy. View next stage. Discover peers. Trackers are central servers that maintain information about peers participating in the sharing and downloading of a torrent. In this stage, you'll make a GET request to an HTTP tracker to discover peers to download the file from. You'll need to make a request to the tracker URL you extracted in the previous stage and include these query parameters: info hash, peer ID, port, uploaded. Ooh, this is a whole lot of things. Okay, so I want to grab these, and then we're going to do... Should really start to split this up a little bit more, arguably. Let's go ahead. Let's make our lives a little bit easier and open a lib.rs, which is going to have this stuff and also this stuff. And I want pub. I'm going to make all of these pub for now. They're all going to be useful to main. This is mostly just to allow us to split things into more files. I don't need those to be pub, because it's not as easy to have submodules for binaries. I mean, you can, but it's kind of annoying. And then I guess we'll do up here pub use hashes. And then we can grab this one. This may be the main one that we want. And then here, what do they call this crate? BitTorrent starter Rust. Okay. With underscores. And I guess we'll just grab all the types from there. And now I don't think we need serde, deserialize, and serialize. Because we just have the torrent files right here. So if I run this again, right, it'll complain about hashes because that's now in this. Still works. That's great. And now that we have these in a lib, now we can do... so now we could even imagine splitting this up into like torrent.rs, which is going to have, I guess, actually all of this. All of that goes into torrent.rs. So we do pub mod torrent. And then we also want a pub mod, I guess, tracker. And you'll see why in a second. It's because I want this type to actually be defined in here too. Pub struct tracker request. Debug clone. Only really needs serialized. I don't think we need to deserialize these. We're not running a tracker server. And then in main now, I suppose we'll do torrent and tracker requests are going to be the main two we need. And so for this one now, we can say info hash, which is going to, let's see. So the info hash of the torrent, 20 bytes long. This is not the hexadecimal representation, which is 40 bytes. Oh, this is the actual like U820. Okay. Peer ID is a unique identifier for your client, and it's a string of length 20 that you get to pick. All right. We'll make all these pub too. The port, so that's a U16. I just happen to know from experience that ports are U16. Uploaded. Okay, so that's an amount of bytes that sort of by definition is usize. Left, also usize. And compact. Whether the peer list should use the compact representation for the purpose of this challenge is set this to 1. So it's a U8, but really it's a Boolean encoded as an integer. Okay, that's fine. All right. So now we have our tracker request. So this is the info hash of the torrent, and it's 20 bytes long. Will need to be URL encoded. That's fine. The library we're going to use for this is going to do that for us. Unique identifier for the client. And so here, I guess we can just use this value over in our main when we make this request, which we'll do somewhere down here shortly. Port. I'm just sort of setting these up for when we later write the code to actually instantiate one of these. Great. The total amount uploaded so far. So that's going to be 0. Total amount downloaded so far is going to be 0. Number of bytes left to download. This will be the length of the file. That's fine. Whether the peerless use the compact representation. The compact representation is more commonly used in the wild. The non-compact representation is mostly supported for backwards compatibility. So we're going to set it to 1. That seems reasonable. So just record that here too. Okay, so now we have a tracker request that implements serialize. And so let's just see what that request would look like, or that URL would look like. So request to the tracker. It's going to be a tracker request. Oh, did I not save librs? Oh, it might be mad at me. Rust Analyzer seems like it doesn't really like when you change the module hierarchy under it. There we go. Fill struct fields. Thank you very much. The info hash is going to be the info hash that we computed, not the hex encoding. That's fine. The peer ID, we're going to set to what they told us to set it to, which is going to be string from. Port, they told us to set to 6881, so we'll do that. Uploaded is 0 because we haven't uploaded anything. Downloaded is 0 because we haven't uploaded anything. Size is going to be the entire size of the file, which we extracted up here as length. And so we can stick the length here. And compact, we should set to 1. Okay, so now we have one of these requests that they asked us to add. The tracker's response will be a Ben-coded dictionary with 2 keys. Okay, so we go back to tracker here, and then we do struct tracker response, which is going to derive debug, clone, and deserialize. Deserialize. No, I wanted all of this. Interval is an integer indicating how often your client should make a request to the tracker. How often? What's the unit for this? Let's go to the spec. Tracker responses are Ben-coded dictionaries. If a tracker response is a key failure reason, okay. Otherwise, it must have 2 keys. Interval, which matches the number of seconds the downloader should wait between requests. In seconds, that feels important. So that's going to be a usize. Realistically, it's much less than a usize, right? Like you're never going to wait for like usize max seconds. Arguably, this can probably be a U8 or something, but let's do usize. Pierce is a string which contains a list of strings. Oh no, one of these encodings again. Each peer is represented using 6 bytes. The first 4 bytes are the peer's IP address, and the last 2 bytes are the peer's port number. This is going to be another one of those fun implementations of a custom data format. Let's do it. It's more fun that way. So we grab our mod hashes thing, and we'll do something similar. So mod peers. So peers is going to be a vector of socket adder, and I know this is a v4 because it says 4 bytes for IP address, so it's IPv4 and not IPv6. So we're gonna have a peers visitor. That's gonna produce a peers. And I guess we can do, for the reason why we expect something, 6 bytes. The first 4 are a peer's IP address, and the last 2 are peer's port number. That's what we expect to get. Visit bytes. I assume it's going to be bytes, because if it's an IP address, then the bytes here are basically arbitrary, so it can't be a string. It wouldn't be a valid UTF-8 string, almost certainly. So that means this should be a modulo 6. Chunks exact 6 slice 6. And so we try into U8 6. We actually don't even need to convert it that way, because we know that it is 6 bytes here, and what we actually want to slice this into is we want a socket adder v4. What are the fields in here? Oh, socket adder v4. I think we need to say like new. Really? It doesn't want to give me that? Oh, right, because I have all these other things here. Okay, peers. Peers visitor. Serialize for peers. It's actually going to be a little bit annoying, this one. Because we're going to have to serialize this at bytes. Yeah. We'll do that one a little bit later. What's it? It's unhappy about something over here. Aha. How about now? Oh, I don't have, that's why. I need to import this. Now am I allowed to do this? Yeah. Okay, so the IP here is an IPv4 adder. And I wonder... Ha! Great. Slice 6, 0. Slice 6, 1. Slice 6, 2. And slice 6, 3. And the port is a U16. So that's going to be U16 from... that's a good question. The port... Is it big endian or little endian? Does the high byte come first or last? And port number respectively. Does the spec really not say whether the port should be big endian or little endian? Why? Why would they not specify the byte encoding of port? It's probably network byte order, I agree, which is big endian, but like... But like, why? But like, okay. 4 and slice 6, 5. And I'm not allowed to use that constructor. Fine. So the reason I use chunks exact here, and the reason I do modular is I think it is a list of peers. Yeah, which contains a list of peers, and each peer is 6 bytes. And so that's why we want modulo 6 here, not equal to 6, and why we chunk it this way. Yeah, but I don't want NE bytes. Oh, yeah, because NE is native. It's not network. And so we wouldn't want which order it uses to be dependent on the architecture of the machine we're compiling for. That wouldn't be right. All right, I mean, we'll see. Luckily, this is something where, at least in theory, this will test and whether it does it correctly. Okay, so this slicing is going to be a little bit annoying because we actually need to... We can't use concat here because it's not a slice of U8s. So instead, what we'll do is single slice is a vec with capacity of 6 times self.0.len. And then for peer in self.0, we'll do single slice dot extend peer dot IP dot octets, and then we'll do peer dot port dot 2be bytes, and then single slice. And now main is complaining at 57 because info hash. Because the info hash we get back from finalize is actually this weird generic array thing. But I think we can just do this, maybe? Okay, so the type of info hash over here is... it's okay. Where's my SHA-1 crate? The result that you get back from finalizing the hash is generic array of U8 and self output size. Now the question is, how can I turn... First of all, where does generic array comes from? That's an excellent question. Crypto common, maybe? What? The file that it claims has this type does not have this type. Someone pointed out, oh, you can just in the function argument here, I could just unpack it. So B1, B2, B3. Unfortunately, that doesn't work because it's not an array, it's a slice. I think maybe I could do like before P1, P2, dot, dot. But the problem is this is a fallible pattern because if the slice is shorter, this pattern wouldn't match. So that will only work when we move to array chunks. And then we can also pattern match in closure args. So unfortunately that doesn't work. Oh right, this has to be now. Torrent keys. Yeah, so the problem is the thing you get back from finalizing a SHA-1 hash is this generic array type. And what we want is an actual array, not this weird wrapper type generic array. And doing that is a little bit annoying because in part I can't find the generic type implementation. It makes me wonder whether, like, can I write U820 here? Is it going to let me do that? No, it's not, is it? But I don't understand where this generic array thing is, because that's from Crypto Common. All right, give me Crypto Common then, please. Does this have a generic array? That comes from the generic array crate. Okay. Core Rust can't be used generically with respect to n. So that I see. So this is a crate that preceded const generics. Okay. Is there a way for me to do it now that it's no longer true? No, there's not, is there? 0.14.5, 14.7. Please tell me one of them added a way to turn it into a generic array. Generic array. Nope. Nope. This is all slice stuff. See, my guess is generic array version 1 does allow you to expand one of these. If I do this. Surely this uses const generics to give you back the actual, into array. I want this one. But we're not using the latest one, are we? Generic array. Generic array. Yeah, they're using generic array 0.14, and 0.14 does not have this method. Okay. I'm surprised that they haven't added a converter to this old version of the crate. That's fine. It's fine. It's fine. It's fine. It's fine. It's fine. We'll just do .try into .expect. This is the generic array 20 is U8 20. Expected U820 found a reference. Oh, that's because this needs to go away now. Great. What do they actually want us to do? Oh, right. This is just so that we can correctly parse peers. And so now we have a new peers command. It presumably also takes a torrent file and it expects to get a list of all the peers. All right. Peers. Command peers torrent. I guess just for our own sanity's sake, we could now do impl torrent and give it a method to compute the info hash. Pubfn info hash self returns you a U820 20. And so now I should be able to do info hash is t dot info hash over here. And as a result, I can do the same thing now over here. Why is it t? Oh, right, because we still need to actually parse the file. That's fine. And then the request, I guess I don't need to do yet, but they're going to ask me to do it at some point. And I guess I don't need the info hash either in this command. There's going to be some later one where I'm going to need this. That's fine. And so here what they want me to do is for peer in t dot... Oh no, they do want me to make a request actually. Never mind. So the request is going to be this. The... I guess tracker response is going to be request URL from, and I want to use t.announce. Right, so I'm basically constructing a URL to the tracker, and so that's based on the announce URL in the torrent file. Dot query pairs mute. Tracker URL is going to be this. And then I guess what I want to do here is pairs is this. Pretty sure there's a better way to do. I don't think this is actually what I want to do. I think what I want to do is tracker URL dot set query. And I want the URL params to be using the SERDI URL encoded crate, which lets you take URL encode any type, which is, you know, what we have. ToString of request wrap, I guess context, URL encode tracker parameters. And now I should be able to set that to URL params. And then I should be able to do a request get. Tracker URL. Oh, this is let's use the sync one for now. Let response is equal to that. If we have the, oh, why don't I get context anymore? Use anyhow context, but I have context. Something's wonky. Oh, it's because, okay, that's fine. This guy needs to go over in this file. Oh, right. This guy arguably now needs to start returning a result. I'm going to just expect here. Should be fine. Some shortcuts are legal. And right, and then this is going to be try into dot expect generic array. I guess I can just steal the same one I wrote over here. Like so. Oh, I guess they haven't brought in the... Fine. So we're going to make this whole thing now be Tokyo main and async fn. Because now this has to do a HTTP request. So await context fetch tracker. Expected URL found string. Cannot find length in the scope. Oh, I see. Okay, fine. So we still need to do this because they're still assuming that the file is single, or that the torrent is single file. That's easy enough. Expected URL found string. Do they have a new instead? They do not. Docs.rs request. Yeah, that's fine, but how do I create a... Can I just make myself a URL instead? Parse. Parse. Parse tracker announce URL. Expected stir found string. All right, reference to that. Beautiful. So I guess now we want peers. Unsupported value. Interesting. We're going to have to dig into that one. So this is saying when trying to URL encode the tracker parameters, this one it's not happy with for whatever reason. Huh. Why? Why? I wish it would give me more context here. Unsupported value is not particularly helpful. It's probably the byte array. Yeah. So if we do assert a URL encode. What? URL encoded, my bad. ToString. Actually, I want to see give me repository. And then I want to search for, what's the error I got? Unsupported value. Supported value. Okay. Okay, I think that's just anything that, right, this gets called for anything that's not one of these. So it can serialize strings, static strings, and stirs, and sum. Really? No, it specifically said it's not hex encoded. So look over here, info hash. Note this is not the hexadecimal representation. It is a URL encoded version of the bytes, which I would hope that the URL encoded crate would do for me. But I suppose not. Which I guess means it does not encode values for me. Regard to bytes. Support serializing bytes. Only deals with UTF-8 strings. Look, someone else is implementing a BitTorrent HTTP tracker. Which have already been percent encoded. This sounds like we could actually just, I mean, we could just URL encode it ourselves, I suppose. I just kind of was hoping that we didn't have to. Because it gets real messy, because now, like, what even should the type of this be? Here's what I think we have to do. We have to do, what's the Surdy trick for this? Field attributes. Serialize with. Serialize with equals path. Copy. Serialize with URL encode. And so then we're going to do this. And I think this has to be a module. Oh, no, function. Okay. So we can do this. And it has to take a serializer, and it has to take a T, which is going to be one of these U820s. And the way we're going to do that, I suppose, is serializer.serialize stir. And we're going to serialize stir. Encoded is going to be URL. Do they even give me a handle for this? They just kind of claim that I can use Surdy URL encoder for this, but I don't think that's actually true. I think what we have to do here is yeah, I suppose we can just manually encode it. It just feels really awkward, right? Like, okay, mute encoded is vec with capacity. So every byte is going to end up being 2 bytes plus a %. So 3 times t.len. And then, 4 byte in t, encoded.push %. Encoded push hex encode byte. I guess string with capacity. And costring encoded. Which just feels dirty. The trait asref is not implemented for you. That's fine. Okay. Like, this just feels gross. Oh boy. What? Oh, right. This should be fine. That's gross. That's gross is what that is. But it works. Like, we get the response back. And then I guess we want the actual response is going to be tracker response. It's going to be response dot. Oh, forgot the question mark. Response dot body dot bytes. And then we're going to do bin code from bytes of response. parse. Ooh, parcel tongue over here. Parse tracker response, and that's going to be a tracker response. And then they want for peer in response.peers print line peer dot IP and peer dot port. Wait, did we not? Did I like not mark it as pub or something? I did not, did I? Pub. And this is a peers. So pub use peers. Great. And we're almost there because this peers has to be response.peers.0. Missing field interval. Is interval required? I feel like the response we're getting here is wrong somehow. What? Failure provided invalid info hash. Yeah, I mean, of course it's the invalid fucking info hash because I guess the encoding did not actually work. All right, what is the actual URL we end up setting here? Info hash. Yeah, see, it ends up URL encoding the thing that we outputted. That's so we URL encode the bytes, and then it URL encodes our URL encoding of the bytes. But we can't give just the bytes because then... Okay, here's the way we're going to do this. Note, the info hash field is not included. This is very stupid. This feels very stupid. So there's not going to be an info hash field. Instead, we're going to do this. And then we're going to do tracker URL, query pairs mute, append pair, info hash, URL encode, and this is no longer going to be taking a serializer. It's just going to return a string. And it still makes me very sad. And the thing it's going to do is URL encode t.info hash. Or I guess we already have it, so info hash. Yeah, thanks, I hate it is right. And it's no longer generic over S either. Provided invalid info hash. It's still getting URL encoded. Why? Is there like an append? What do we have here? Extend encoding override. Oh boy. Oh boy. Am I really going to do this? Is there really not just a okay. Request URL. Show me what you got. Okay, so we have query pairs mute, which gives us back a serializer. Manipulate this URL's query string viewed as a sequence of name value pairs in encoded syntax. Yeah, I can append Unicode, but that doesn't help me. Okay. URL query. These all require strings. And serializer is not a public type. Okay, where does that comes from? Form URL encoded. Okay. Form URL encoded. Serializer. What we got here? Set the character encoding to be used for names and values before percent encoding. Before percent encoding. That's not what I want either. I don't understand. Why isn't there a way for me to just set bytes in the URL? Bytes. Allow non-UTF-8 key and value pairs. Okay, that's not super helpful. No, the encoding override is used instead. I guess the question becomes... Okay. Encoding override. Some. No, because the input to this still has to be a string. And this is not a valid string. That's sort of the whole point. Okay, so that's not going to work. Yeah, I suppose the way we have to do this actually is then just tracker URL is going to be format t.announce URL params and this. Now, the reason this is awkward is because if there are query parameters in t.announce, this won't do the right thing because you would end up with multiple question marks in the URL. Um, what? It cuts off the entire query string. Why does it cut off the entire query string? That's wild. Okay, so I guess we can just not go through parse. Just don't parse it, just pass it straight to request get. Okay. So if you pass it to get, which presumably has to turn it internally into a URL, then it's okay with it. But if you pass it via request URL parse, then it doesn't work. This is just wrong. Like this is just wrong, and this should not be the case. Oh boy. Yep. Okay, fine. Well, it does the thing. It does the thing. That's just okay. Great. Thank you. All right. Well, we did the thing at least in theory. 178.62 with port ends with ND. The port is wrong. The port is fucking wrong. Look at it. The port here 51470. The port here 514. Wait, the first what? Oh no, they're just in a different order. Why are they in a different order? Okay, so we are parsing the ports right. So it is big endian. Okay, I was about to say. But why are they in a different order? Are they in a different order each time? Split files and split modules and contact tracker. Let's see what happens if I push. The values are random in the instructions. Okay. Well, I guess we'll see. I would just like assume that they shouldn't need to be ordered. All right. Well, I guess we did it. Nice. Okay. Peer handshake. In this stage, you'll establish a TCP connection with a peer and complete a handshake. The handshake is a message consisting of the following parts as described in the peer protocol. So that's also further down here, the peer protocol. Okay, let's close some of these. Just because otherwise they're going to continue to make me sad. Okay. The length of the protocol string. Wait. Peer connections is symmetrical. Message sent in both directions look the same and data can flow in either direction. Peer wire protocol consists of a handshake followed by a never-ending stream of length prefixed messages. The handshake starts with character 19, followed by the string BitTorrent protocol. The leading character is a length prefix, but they're in the hope that other new protocols may do the same and thus be trivially distinguishable from each other. All later integers sent in the protocol are encoded as 4 bytes big endian. So here they specify endianness. Okay, great. After the fixed headers come 8 reserved bytes, which are all 0 in the current implementations. If you wish to extend the protocol using these bytes, please coordinate with Bram Cohen. Okay. To make sure all extensions are done compatibly. Next comes 20 byte SHA-1 hash of the B encoded form of the info value from the meta info. Okay, this is the info hash. except it's raw instead of coded, okay? If both sides don't send the same value, dissever the connections. Okay. So this is fine. So the handshake, let's go back into here. We'll go to lib. We'll do a pub mod handshake, or peer. Peer is good. I like peer. 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 Pub struct handshake. Now, this one I actually think is going to be kind of interesting. So I think what I want to do here is actually a maybe I want to do something quite unsafe here, which is I want repr C, and then I'm going to say this is going to be the length, which is a U8. It's BitTorrent, which is a U819. It's 8 reserved bytes. 8. Then it is a SHA-1 info hash, which is U820. And then it's a peer ID, which is a U8 also 20. Oh, what did I even do there? Okay, these are all pub. No, semicolon. Okay, so now in my main, what's the... Okay, so there's a new handshake now. And handshake is supposed to take a torrent and a peer, where the peer is peer IP and port. That's fine. That'll be a string. So if we get a handshake, we do this, we do that, we do peer is peer dot split ones on a colon. Actually, we can just do I think socket adder v4 lets you parse peer. Parse peer address. Oh, there's a URL parse with params. Interesting. That's fine. I'll leave it the way it is now. Okay, so we parse out the peer, and then we just do a straight TCP connection to it. Okay, so peer is, I guess, Tokyo Net TCP stream, connect to peer. Connect to peer. And then we want to do peer.send. And this is where it'll get tricky. So handshake is going to be a handshake like so. Rust Analyzer really doesn't like when you make new modules in the middle of writing. Now it's going to tell me where it is, I think. Lib. Oh, it's because I don't even import it. Peer handshake. There we go. The length is going to be, should always be 19. So I guess actually to make this a little bit nicer for ourselves, we'll do impl handshake pubfn new, and it's going to only take info hash, which is a U820, and peer ID, which is a U820, and return a self. And the length is going to be 19. BitTorrent is going to be the string BitTorrent protocol. And to be clear, like the reason why they do this, right, is because, or the reason why this length here is hard-coded, but is still present, is so that you could have other strings of different lengths, and you can still decode them like this. Now, given that we know this is always 19, we could just do it that way for right now. 0, 8. We could write a full parser for this that like does a length encoded string decode, but because we know it's 19 and it's fixed length, how about we just do it nicely? So we do handshake new, and what's the... Right, so the peer ID, we can use this thing, and the info hash we already have. And the reason I make it mute here is because I actually want to use this to read the thing back out to. You'll see in a second. So I want to write, and I guess I gotta use Tokyo IO async write text. Write all, and I want to do a at handshake as U8 of length mem size of handshake. Right handshake. Now this is almost certainly unsafe. It should be at least. All right, star of that. Something here, star of that. Mem size of, this is not a runtime argument. This is a compile time argument. Non-primitive cast, yeah. So this is where it'll actually be this as const to this. And then it'll be unsafe. Well, all right, let's do this a little bit nicer. So handshake bytes is going to be this. And then this is going to be unsafely turning that back into handshake bytes. Casting a reference to handshake as, oh right, I need to do const handshake to cast it all the way. And it's upset about my socket adder v4. I thought there was a parse. Is there really not? I think it's peer.parse. I'm pretty sure this supports like from string. Yeah. Write all dot await. So what I'm doing here is I'm constructing one of these handshake things, and because the struct is repr C, that means that I can treat it as a byte array. It's not really what it means directly, but indirectly it means I can treat it as a just series of bytes. Like I just take the bytes that are in the in-memory representation of the struct, and then I take that and just cast it into a byte array of the appropriate size. And that thing I can then cast back into a reference to a byte array instead of a raw pointer or reference. And that in turn, I can then pass to write all, which takes a slice. And now it's upset that this needs to be mute, which is fine. And I guess... Actually, I guess that's a good point. I need to find a valid peer. So handshake to this thing. Oh, right. Okay, great. So I wrote it, but I didn't get anything back. So now, here's what I want to do. I want to do peer.read all. Handshake bytes is going to be a mutable reference to a U8 of this length. So I'm just turning handshake bytes into a mutable reference over the same thing. I'm passing that into write all, and then I'm going to pass it into read all as well. So I want, I guess, read ext as well. Async read ext. And then I want a dot read exact into handshake bytes. Dot await, dot context, read handshake. And so now I want to do some assertions on this thing. Like I want to assert that the, I guess I'll drop the handshake bytes thing is only valid within here. And now I want to check that the handshake, which remember, I passed in a mutable reference into this thing. So after the read, the contents of this struct should now be the bytes that we got from the other end, the other side's handshake. So I should now still have the case that the length here is 19. It should still be the case that BitTorrent reads whatever BitTorrent was supposed to read, this thing. And it should also be the case that reserved is equal to 0, 8. Right? Casting. Oh, right. This has to be mute now because I want it mutable. Can't compare U819 with U819. That seems like a lie. I want to. Oh, I forgot parentheses. Assertion failed. Oh, they do set reserved bytes. The reserved bytes are supposed to be all 0. Why are the reserved bytes not all 0? That's kind of interesting. We certainly set them to all 0. I know extensions use them, but like this like what's it called? Codecrafter's peer presumably doesn't, but that's fine. Okay, we can just ignore them, I suppose. And then what they want us to do is print out the peer ID hex encoded. Okay, so print line, and I guess this actually means that we don't need the length in this particular exercise. Peer ID, this would be hex encode, handshake dot peer ID. Now, the only reason why this casting here is actually okay, I should probably write a safety comment here. So handshake is a POD with repr C. POD here means plain old data, which means that any byte pattern is valid. So you see the types in here are all valid for any byte pattern. So there are no sequence of bits that would make any of these types have an invalid or value with undefined behavior. They're all values are valid. Okay, so basically, no matter what the other end sends us back, any bit string is a valid interpretation of this struct. Great. So if I now run this, I get back a peer ID. I wonder if it's happy with that. Like, print peer ID. Hit push. Let's see. Yes. All right. So we correctly handshook with a peer. Next stage. Download a piece. Ooh, this is hard. All the other ones have been easy, supposedly. In this stage, you'll download one piece and save it to disk. In the next stage, we'll combine these pieces into a file. To download a piece, your program will need to send peer messages to a peer. The overall flow looks like this. Read the torrent file to get the tracker URL. Perform the tracker get to get a list of peers. Establish a TCP connection with a peer. Perform a handshake. Okay, we've done that. Exchange multiple peer messages to download the file. Okay, peer messages consist of a message length prefix, message ID, and a payload of variable size. Here are the peer messages you need to exchange once the handshake is complete. Wait for a bit field message from the peer indicating which pieces it has. The message ID for this message type is 5. You can read and ignore the payload for now. The tracker we use for this challenge ensures that all peers have all pieces available. Send an interested message. Wait until you receive an unchoke message. Break the piece into blocks of 16 kilobytes and send a request message for each block. Interesting. Okay, so this doesn't seem too bad. This doesn't seem too bad at all. So there are a couple of ways we could do this. We could either actually write out a codec. Maybe that's actually what I want to do here. Because presumably there's like a format for each of these messages here too. I guess interested has no payload. But we could actually use Tokyo Codec for this. So Tokyo Codec basically lets you... this crate is deprecated in Tokyo and moved into Tokyo Util Codec. Okay, that's fine. Yeah, so this is a way to convert between an async read and an async write to a stream and a sync. So sync is a thing where you can send values in, and a stream is a thing where you can take values out that are well typed. Whereas async read and async write only work on the sort of byte level. This does tend to make the protocol a little less efficient because you go via this sync thing, so you don't get to... it makes memory management a little bit less nice, but at the same time, it can be very, very convenient. You get a much nicer interface on top of the protocol. So I think what we'll do here is, so let's go to peer. So there's going to be something like Certi. If we can do this with Certi, that'd be cool too. And I think we probably can. Um, so what I really want to express here, right, is something like enum message or peer message or whatever it is, but message because it's in the module peer. And then we have, what was the example? So bitfield is one message type. And what I really would like to express is something like, I guess message type. And then we do something like repr U8. And bitfield is message ID 5. Right, so we can encode all of these, like interested is 2, unchoke is 1, request is 6, piece is 7. And who knows what the other things are. Okay, so we have 1, 2, 5, 6, 7. So those are the sort of message, I guess message tag is really the appropriate one. And then I want to say enum message. And then I suppose what I really want to say, right, is that the, where's the surdy? Docs is bright. I'm apologizing, a little bit too late. Field at no container attributes. Tag. Enum representations. So for tags, you can say, this is like the name of the field that holds the tag for which variant you have. Now, this is a little weird in this protocol because there's not a named tag really. I think this is going to be a little bit weird in surdy land. So I guess then what we really have is a struct message, which has a tag, which is a message tag, and a payload, which is really just a vec of U8s. Yeah, I think what we'll do here is we'll do a codec and just see how that turns out. So let's write a little encoder and decoder. So we'll grab both the encoder and decoder in the same thing here. This all goes at the top. Am I bringing in the same thing multiple times? No, I'm not. Okay, so what I want is message decoder. So implement decoder for message decoder. And the thing message decoder is going to produce is a message. So it's going to be given a bunch of bytes. And we know that the length in this protocol it's always a length prefix of 4 bytes and a message ID of 1 byte. So it should be at least 5. And then I guess the length, let's read the length marker first. Let's do 5 marker plus tag. So then we return OK none to say there's not enough data available for us to decode a full message. And then we read the length bytes out of the slice. Does it say whether they're big endian or little endian this time? It did, right? Pure messages. Oh, here are the other ones listed. Let's stick those in there while we're at it. Not interested is 3, and have is 4, and cancel is 8. Yeah, I think it said or all later integers sent in the protocol are encoded as 4 bytes big endian. Okay, great. So that means over here, we could say from BE bytes. So that's the length. I'm not too concerned about this one, but I guess we know that the payloads you can get, I guess piece is probably the thing that choke. So pieces are, I think they said somewhere the pieces are not larger than, 16 kilobytes. Usually 2 to the power of 14 bytes. So max here is actually going to be 116. Or I guess 14. But it's 114, but it's plus the headers. And I also don't know that we want to use the max here. So let's do 16. Great. If the source length is, does the length include the mandatory tag? Okay. Yep. Messages of length 0 are keep alives and ignored. Okay, so there are messages of length 0, which means the messages of length 0 have no tag, which means that the tag length is included in the length. Great. Here we can just keep the stuff from the example encoder. That's fine. So this is if the bytes, so we're giving a byte buffer here, right? If the byte buffer's length is shorter than how long the length field says the packet should be, then we reserve some more space and then we say we don't have enough data yet. Otherwise, that means we have enough data. We have every data that's supposed to be there according to the payload length in the header. And so therefore we extract out everything following the length. And I think actually what I want to do here is I want to grab the tags separately. So I want tag is source 5, and then I want data is 5 to 5 plus length minus 1, which is 4 plus length, but wait, that's not right. 4 plus length minus 1. The reason I want to do this is because the vec that we extract here, otherwise that vec would have a tag at the beginning, and then we would need to allocate a new vec to hold the actual data bytes, which we would then need to copy all the bytes into that bit, which just seems unnecessary. So we advance it by 4. We don't want to convert it to a string. Instead, what we want is, at this point, an OK of a message with tag and the payload is data. So this is just the framing protocol, really. Expected option. Oh, right. Sum, because we successfully decoded the next thing. Oh, did I grab the wrong code for encoder? I think I did. Aha, example encoder. That's what I wanted. The payload data contains the tag. No, it does not contain the tag. We pulled that out first. Oh, choke is equal to 0? Did I miss one of the... Oh, choke is equal to 0. How about that? Choke is equal to 0. for so this is then down here. This is going to be message encoder. And really, we could just call this whole thing message framer, right? Because that really is what it is. It frames for both decoding and encoding. And this can encode anything that is of type message. So item here has to be message. And really, we could do even better here, actually, which is to say, this is going to make our lives a little bit easier in the future. So we could have a trait here, which is a message that we implement for multiple different types. Because okay, let me backtrack a little bit. So the awkward part here, right, is that the tag that we pull out is separate from the payload, which is a VEC-U8. So we're going to need to have some code somewhere that like matches on tag, and depending on the tag, deserializes the payload. In reality, which tag you get dictates what type payload should have. So it would be kind of nice if there was a way to express that. But there's not an easy way to do this with SERDI because it sort of expects fields to have names, which isn't really true here. I suppose we could make message generic over T, and then if T be some kind of enum, doesn't feel quite right. Yeah, I think we're just going to keep it this way, and then we'll just, because this is also a sort of test implementation, if you will, I think it's okay for us to end up with a with that match. It's okay. I won't do the trait thing here either. Don't send a message if it's longer than the other end will accept. That's fine. If item dot payload dot len +1 because of the tag. Or did we count in the tag here when we check the length? Yeah, we do. So if this +1 is greater than max, we're going to refuse to send it. The length is going to be payload.length plus as u32 +1 to big endian bytes. 4, so that's the length, +1, that's the tag. Plus the length of the payload. So we want to reserve space in the buffer for all the bytes we're trying to send. And then we extend it with the length slice. We also, is there a push or put? Put, yeah, put u8 of item.tag. And then payload.askbytes. So that's our encoder, that's our decoder. So now we have this framed thing where we should now over in over in main. Oh, what's the actual command they want us to add? So the command is download piece. All right. Download piece. Supposed to be arg short output is a path buff. Torrent is a path buff. What's the 0 here? Oh, this is, and then which piece, I guess. Great. So if we get a It's a little annoying to split these into so many subparts. But it's okay. Download piece. We could also pretty easily start to refactor this so that these pieces of code are just like contained elsewhere. But I don't want to do that yet. Torrent, output, and piece. So we still need to parse the torrent file. We still need to grab the info hash. We still need to do the handshake. We do the handshake. I suppose we don't actually know which peer to connect to. Should we just connect to a random peer? I guess we can connect to as many peers as we want, really. Or we could connect to a random peer. Yeah, all the peers have all the data. So I think instead what we'll do here is we'll just connect to a single peer for now. So we'll do t.info. Wait a second. No, we need to, right. We need to string all this stuff together. Like, it's awkward that we have to support all the previous test cases still, because otherwise I would not have, I would just not keep this old code around and have to copy paste it, but fine. So we do this, parse the torrent file, compute the info hash, send the tracker request. That gives us back the response. And then I want this to have a better name than response. This is really tracker info. And then peer is going to be tracker info dot peers dot 0. We're just going to pick the first one. Then we connect to the peer. We do the handshake. Now we have the peer ID. Okay. And so now the next step arrives, which is when you have one of these codec things, what you can do is, where's the example of calling it here? So now I can do this. I can create a buff. I can take the peer connection, read into the buff. Wait, no. Yeah, I don't want the equivalent to the following loop. I want the actual framed. Where's framed? Here. This is what I want. So I want I don't want all this ugly code. Tokyo codec takes care of that for me. So peer is now going to be Tokyo util. Can I add to Tokyo util? Any changes here will not reflect when code crafters test your code. Really? I don't get to use Tokyo codec here? I can add things, but it says changes here will not reflect when it tests your code. We added support last week. You can edit and save. All right. I will trust this random person in chat. So Tokyo codec, no, Tokyo util version 0.7. If they added this, it makes me very happy. Are there feature flags? Yeah, let's do full. That seems fine. All right, so Tokyo util codec framed new, and I want then the peer, and then I want handshake and message tag message and message framer. And where's my message framer over here? There's no real need for it to have fields. Now I have a framed thing over the peer, and now I should be able to just use that as a stream and a sink. As you see, it implements now, framed implements stream and sink. And this means that I should be able to now go back to, let's see, where's the... So the stream trait and the sink trait, it gets from futures sink and futures core. Okay, so let's pull those in here. So futures core 0.3 and futures sink 0.3. And now, if I remember correctly, I should be able to just do while let. I guess I know that I'm first supposed to wait for a message. So I'll do message is peer dot next dot await. Let me see if this even does anything useful. Karutomo Tokyo util. Peer. Let's go bytes, bytes, buff mute. Okay. This as U8. It's easy. Payload.len. Right, this doesn't need to be to vec. And this should now be... Right, this is where this gets awkward because any arbitrary byte is not valid as a message tag, but any message tag is valid as an arbitrary byte. So what we really need to do here is we need to match on this byte, and we need to say that U is... Really what I want is like a message tag try from here, but I don't think you automatically get one. So I'm actually going to do this mapping manually, which is there's a crate that helps with these. That basically lets you derive the try from here. And having this mapping in two different places is obviously not ideal because it means that you might accidentally update one but not the other, and they get really hard to debug problems as a result. All right. And then if I get anything else, I guess I will return one of these. Oops. Unknown message tag. Message type tag. And somewhere here too, it's unhappy. It doesn't need as bytes because this is already a byte slice. My string framer. This should be message framer. Aha. We're getting there. We're getting there. This needs to be pub. 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 Main 196. Next. Right. So now I want futures util because I want use futures util stream ext and sync ext. Really? I'm pretty sure there's supposed to be a sync x2, but let's do stream x for now at least. Cannot borrow peer as mutable. That's easy to do something about. Amazing. Okay, so now we get a message, and we should be able to now do like an ePrint line of message.tag. So let's see what message tag we get. Right, so this is going to be, it's an option. So we're going to unwrap because we know we're supposed to receive a message. So I guess, yeah, we're going to do expect peer always sends a first message. It always sends a bit fields. And then context as in, if we do get a message, it should be a valid one. Peer message was invalid. Message tag cannot be formatted with the default formatter. That's easy to do. Message can derive debug and clone. And message tag can even derive copy. But not display. That's fine. Let's see what we get. Ooh. Oh, right. This is because I'm calling handshake. I need to call download piece. I don't know, foo. Actually, do they give like a... Oh, they just use a temp file. Okay, so if I do this... Okay. They give you clap to work with, but then they use the wrong subcommand shortening for that clap uses. So this, I guess I need to do clap rename equals download underscore piece. All right, clap. Derive reference, rename. I guess I will have to do rename all snake case. That's fine. Peer message was invalid. Unknown message type 224. That does indeed seem like an invalid message, doesn't it? ePrint line. Let's see what length it claims this first message has. First message has length 2. Interesting. That doesn't seem right at all because they say wait for a bit field message from the peer. Like there's not supposed to be any 224. Wait for a bit field message from the peer indicating which piece it has. Message ID should be 5. You can read and ignore the payload for now. A length of 2, you say? Can they send you wrong messages until you get a bit field message? I assume not. Like, it'd be very weird if the peer just sent you random garbage messages, right? At least like a length of 2 is not entirely unreasonable. It's tag plus 1 byte. But the 224 as a tag seems odd. And we know that we're parsing out the peer ID correctly because that's what the previous step like tests, right? So the next 20 bytes is the info hash. After the download hash comes the 20 byte peer ID. That's fine. We don't they're supposed to validate peer IDs, but I guess we don't do that. That's fine. That's for handshake. Next comes an alternating stream of length prefixes and messages. Messages of length 0 are keep alives and are ignored. Keep alives. Right. This is actually something we should implement, which is if this needs to be 4 because we have to allow for there to be heartbeats. And so now, if length is equal to 0, this is a heartbeat message. Discard it. Now, there's an argument here about whether heartbeat messages should be discarded or whether we should emit them as like a none, like a no message. I think I actually want to just discard them here. Like realistically, you might actually want to bubble these up so that the sort of caller can keep track of which peers are actually alive. But for our implementation, it's going to be annoying to like, we would have to make message here. And I guess it could produce another option wrapping here, right? But I don't really want to do that. We can't easily add anything to message tag because it's supposed to be valid for all U8s. Like I don't want to have like message tag 255 mean heartbeat and then some protocol decides to extend it and put semantic meaning to that value. So we don't really have a way to represent up the stack a heartbeat message. So I think I just want to discard it here. The way that we have to do that is we have to do here. And then what I want to do, so we need to advance the source past the heartbeat. And now this is where it gets awkward because imagine that the source buffer here actually had 2 elements in it. So we're sort of supposed to either return none if there's not enough data or some if there is. So there's actually a case here where you would need to recurse or you would need to sort of loop, like you would need to try again in case there's another one. And I guess we can just actually recurse here. This is an unlikely case to happen very often. And then try again in case the buffer has more messages. So we do return self.decode source. So we advance past the heartbeat, and then we just try to decode the next message. And then we have to do if source length is less than 5, then not enough data to read the tag, in which case we got to return okay, none. That's not going to be the cause of this, but it's just interesting. Okay, so I guess we got to print out these bytes then. So we get the length. And then here, I want to eprint line. I suppose a hex encode of four to 4.length. 05E0. What? Why is 05? 0.5 should be parsed as 5. Why does it say 224? I think E0 is 224. I think we just have an off by 1 here. We actually do, because I'm completely stupid. This should be 4. The tag is number 4. The data is 5 and onwards. Okay, good. Great. Fantastic. Great. So I was just being stupid. Beautiful. Great. Okay, so we got a bit field. We printed out. It is indeed a bit field. Okay. Well, we're not done yet. This is just, we got a bit field. You can read and ignore the payload for now. The track we use for this challenge ensures all peers have all pieces available. I see. So there's a, we assume that so this is going to be, I suppose, bit field. We assert equals bitfield.tag is message tag bitfield. Bitfield covers all pieces. Send an interested message. Okay. Payload is empty. Okay, so now we can do, again, because we have this codec, we can do peer.send, and we can send a message which has a tag of message tag interested and a payload of nothing. Interested message. And I think now it's going to yell at me because send isn't found. Oh, this is another thing we should do over in peer, is that message tag should implement partial unique, just to make life a little easier for ourselves. Send doesn't work because futures util is supposed to be, yeah, sync ext. That's what I thought. But why doesn't it let me do that? Unresolved. Found an item that was configured out. Thank you, compiler. Feature flag sync. All right. Version is this. Features equals sync. Well, it didn't crash on us. So I guess that means it compiled. So this send is now going to send that message. And then it will be encoded using the length encoding through the framer. And so now wait until you receive an unchoke message back. Okay. So now we should do let unchoke. Unchoke. And here we're sort of hard coding the protocol, right? Where we sort of assume that every time you send an interested, you get an unchoke. Really, we should encode this as like a full state machine, so that we could reuse it when we want to request different pieces from different peers. But this is just to see that the basic flow works, right? We should get an unchoke. The payload should be empty. So this should be unchoke. Unchoke.payload.is empty. Break the piece into blocks of 16 kilobytes. And send a request message for each block. Okay. So now we need to do this this splitting thing. Break the piece. Okay, so we need to pick a piece first. T.info.pieces. The number of bytes in each piece the file is split into. I want to see what the spec says here. This is not break the piece. Which the piece? I guess the piece we're going to download. All current implementations use 2 to the power of 14 and close connections will request an amount greater than that. Okay, that's fine. Downloaders generally download pieces in random order, which does a reasonable good job of keeping them from having a strict subset or superset of the pieces of any of their peers. Okay, so I guess we're just going to pick a random piece, which means we might as well just pick piece 0. There's nothing in the argument here that oh no, it is. Okay, we do know what piece to pick. It gives us the argument, right? Okay, so the piece hash is going to be the pieces. I guess we should have an assert at the beginning here that piece is less than t dot pieces dot len. Oops. So that here we can do piece and let piece size is going to be if piece is equal to t.info.pieces.len, else. In fact, do we even need to send the size? Yeah, this will be 2 to the power of 14 for all blocks except the last one. The last block will contain fewer. You'll need to calculate this using the piece length. Yeah, that's what I figured. Okay, so the full length we're going to download is the one we have up here because we still assume single file. So if the piece is equal to the last piece, otherwise, I guess we'll have a constant up here. So this is something like piece max is 2 to the power of so. So then it's piece max, or if it is the last piece, then it will be length modulo piece max. Is that right? Yeah, the remainder after dividing by piece max. Okay. And that means we should now have let mute request is going to be a vec. In fact, we have a couple of options for this. I think what I actually want here is I want to do the struct thing again, and I'll be nice and stick it over in peer. So we're going to pull the same thing that we did with handshake. We're going to do a sort of cast here. So a request is going to be the index, which is a 0-based piece index. And remember, all of these are big endian encoded 4-byte integers. And so what I want to do here is U8 of 4. And I actually don't think I want these to be pub. I want these all to be set. So it's index, begin, and length. And then I want an impl on request, pubfn new, and it'll take an index, which will then be a U32, a begin, which will be a U32, and a length U32. The last param was the piece. Oh yeah, we haven't gotten to piece yet. Okay, so this will then construct a self, and it can now basically enforce the fact that these will be big endian encoded. So we can do U32, or actually we can just do index.toBe bytes. We do the same for begin, and we can do the same for length. And similarly, we can do index and have that return a U32 by doing self.index or U32 from B bytes. And so that way we sort of can't use this incorrectly from the outside. So now I should be able to let request is, should really just grab star from here, I think, is request new. Index is going to be the zero-based piece index. Okay. Begin is going to be the zero-based byte offset within the piece. Oh, I see, because you're downloading multiple blocks of a piece. Okay, let's try to download just like the first block for now. So this is really then not the number of pieces, but the number of blocks. Okay, so we're going to have to do piece hash, let the number of blocks is going to be... I guess the piece size is this. The number of blocks is going to be the piece size divided by piece max. That's also not quite true. That'll be an off by 1. Right, because we want if the piece size perfectly divides piece max, then I guess this is actually not piece max. This is block max. The pieces is the hashes. But does it? I see. So this is actually, I see. This is actually not quite right. This is going to be t.info.p length. So p length is the field that dictates, the number, basically the size of each piece. And then the number of blocks is going to be the piece size divided by the block max. And will that work even if they don't divide evenly? I think this has to be, this is like an old trick of block max minus 1 divided by, so this basically ends up rounding up. The one rounds up. And so now I guess we want for every for all the blocks we want to request, and the piece we want to, the block we want to request is I here, or if you will, block. So we have the index is the piece index. The offset is going to be block times the block max. And the length is going to be the length of the block. And the length of the block is going to be if block size is if block is equal to m blocks minus 1, then it will be piece size modulo block max. Otherwise, it will be block max. And now that's going to be the length is going to be the block size. So that's the request we're going to want to send. Send a request message for each block. Now, let's start by downloading these serially, I think. And then we could do yeah, there's a nightly function for doing this the equivalent of this. I think we'll download the blocks serially first, and then we can download them in parallel later. So we send a request. So we do peer.send message. And this is where it would actually be really cool to do zero copy. Doesn't really matter here, but like, you know, like from at request as const request as const u8. I actually want where's my handshake trick? I kind of want to the cast we did here too. So let's go back to the main handshake bits. Let's make this a little less bad. As bytes mute, and then I'll do the same for the other one. So this will be like so. And then we can do the same thing here for requests. Self, 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 bytes, 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 bytes. And in fact, now that it just talks about self, it can be identical up here. And so now we can do handshake bytes is handshake.asBytes mute and get rid of the unsafety from up here. What? Oh, I misspelled mute. So now I should be able to do the same thing. I should be able to down here say let request bytes vec from request.asBytes mute. This vec from is going to end up doing a mem copy, which is a little sad, but you know, we'll survive. Wait, context, send requests. We can even do this to make it send request for block, block. And then when we send that, we're supposed to get a piece message. Piece is supposed to be the message we get back. Piece.tag is supposed to be a piece. Assert not piece.payload is empty. The payload of the piece message we get back is supposed to be whatever this thing is. Okay, so we'll go back here. We'll say So requests. Wait, did I not do that right? I did not do that right. So this should be a piece. And a piece is supposed to be an index, a begin, and a block. And the block here is of unknown size. So it'll be interesting to see whether we're allowed to do unsized last field. Almost certainly not. I can't construct a new one of these, but I can grab the index and the begin. And the block. All right, so I should now be able to do, like, piece is piece dot payload. So what I want to do here, right, is the payload is just the raw bytes, and I want to cast it into this piece type. So I want the reference to that to be this might not work the way I want it to. Const u8 as const piece. See how happy it is about that. Like, if I run this, does it compile? Oh, I accidentally copied some code I didn't intend to somewhere. I copied message tag up here. That was not on purpose. piece.payload.as pointer. So what I'm trying to do is I'm casting the payload to be a raw pointer to one of these structs, and then I'm turning that raw pointer into an actual reference to that type so that I can access its fields. And the trick I'm trying to pull, and we'll see whether it works, is you're generally allowed when you have reproceed for the last field to be unsized. So you notice here, this doesn't have a size. It's just a U8 slice, which normally is, you know, it's not sized. It doesn't, you don't know how long this slice is. And it's also not an array. Normally it's allowed for the last field to be that because you make the type sized by storing it in a reference, and the reference knows its own, it basically becomes a fat pointer. So it also stores its own length, which then stores the length of the last field. So at least in theory, this should be okay. Can I cast thin pointer to fat pointer? Yeah. How are you supposed to do this, though? Let me just get rid of some of the other compiler warnings here. And yes, I'm doing some type crimes here with overflows and such, but you know, such is life. I just want to get it to the point where only that part is the one that makes us sad. 53 pieces, len. What? Info.pieces. .0.len. This is all just because we have the we have hashes, which is this new type. That's why I need all these zeros. I could implement deref for hashes to make that problem go away, but I don't want to. And the reason I say I don't want to is because it's not like it's a bunch of reorganization of the code that's not super interesting really. So I want to focus on the relatively interesting parts. Okay. So here it's now giving me just that one piece where it's complaining. So it wants me, I'm wanting it to cast a thin pointer, so a pointer to a U8 to a fat pointer, which is a piece. But I think the way to do this is, I think there is a way to do this cast the way that I want it to. Yeah, so fat pointers are, for dynamic dispatch, it is the pointer to the vtable, and for a slice, it is the length. And for a reference to an unsized struct whose last field is unsized, it is the length of the last field. And so that last part is the one I'm trying to take advantage of. And there is a way. Oh boy. Yeah, I mean, I can create a raw slice, but that's not quite what I want. I actually think that the way I have to do this is this. So now it's a slice as this as that. It's not telling me I can't. That's not terrible. It compiles. It's complaining somewhere here. Peer at 182. Slice index starts at 5 but ends at 4. What? Oh, I see. It only has a tag. And so this is, let data is if source.len is more than 5, then this else. Rec new. That worked. I got a piece. Well, I got a block of a piece. Interesting. Yeah, so now I can start actually checking the integrity of the pieces by bringing all the blocks together. So I guess now I should be able to do let all blocks vec u8. Let all blocks is vec with capacity piece len. And then I should be able to do all blocks dot extend piece dot block. And at the end now, where's my SHA-1 code? Where's my SHA-1 code? Oh, it's in tracker? No, it is in torrent. Oh. Ah. I have a thing in 10 minutes, so I need to be fast here. Let's see. So if I update this with all blocks, hash is this, and then I guess assert equals the hash with the piece hash, right? In theory, if I haven't completely messed up, Use SHA-1 digest. I'm definitely doing something wrong. $229. Oh, piece size. What? Why can't I? Oh, right. U820. Can't compare U8 with U8. That's a lie. Can't borrow all blocks is mutable. That seems. Well, we get the wrong hash. That's awkward. Why do we get the wrong hash? I guess we should also like, oops, assert eq that all blocks.len is actually equal to piece size. Aha, we don't get all the pieces. Well, we don't get all the blocks. In fact, we get one but not two? Piece size divided by block max. Like, am I only downloading one block? No, two. Piece.block.len. Something's not right here. Because look, we're downloading first a block of that size, and then a block of that size. Which doesn't seem right. Given that the total size is this. What if I just make that 3? Then now I have too much data. I don't think this one's wrong. I mean, I could make it smaller, I suppose. No, there's something wrong in our... I think it's maybe in our modulo computation here. Oh, that's because this should be... No? Assert equal that with block size. Yeah, we're not getting back blocks that are the same size as what we request. And that could be because this one's wrong. There's 7 too short, in fact. Seven is Like, is this just like stupid? Like I need to tell it to also include space for the headers? No. Well, okay, here's the problem. I have another meeting I have an actual meeting in 5 minutes, which means I actually have to stop, which is very frustrating. So there might be a part 2 to this one. But it seems like we're very, very close and we have a one-off here somewhere. I guess I could try one last thing, which is 1 to 15 and see what happens. Oh, or where's our encoder? Peer, where's our const? No, encode, max, where's our max? No. We have a bug here somewhere that's like off by 7. I'm a little unclear why. But I do really actually have to stop. And so I think this was pretty fun. I think this was a good way to like guide you through something interesting. I think having the tests and having the steps was pretty useful in guiding you through the actual protocol. I think I would recommend this. I've talked about this in the past that I think it's a really good way to learn to build real things. And this certainly forces you to write like real code to do interesting things. And afterwards you get to have like a real BitTorrent client, which I think is pretty cool. I'll give this a sort of endorsement, if you will. What I'll do is I'll put the link in chat for where you can try this on your own. So it's this is really fun. I might just continue this on my own. So Codecrafters gets a +1 for me. And again, I don't actually get paid to tell people to do this, but it's like this actually seems like a good idea. I like this way of teaching. And with that, I'm going to stop. Thank you all for watching. So much fun. And I hope you had as much fun as I did doing this. Thank you all for coming. I'll see you all later.